All right, let's talk about something that feels, well, kind of like magic. We're going to pull back the curtain on computer vision. It's the incredible science that gives machines the power of sight, and trust me, it is absolutely everywhere.
I mean, really think about it for a second. How does that little yellow box just snap perfectly around someone's face almost every single time? It's not actually magic, but it is brilliant. And today, we're going to figure out exactly how it works.
So yeah, we're going to treat this just like we're revealing a magician's best-kept secret. Because once you understand how it's done, you'll see this incredible feat for what it is, a series of really clever, logical steps. Okay, so here it is, the first big secret. When we look at this picture, we see a dog, we see fur, a happy expression, a friend. A computer, it sees a spreadsheet. That's it. To a machine, this image isn't an animal, it's just a massive grid of numbers, where every single dot has a value for its color. So, if the entire world is just a giant wall of numbers to a computer, how does it even begin to make sense of any of it? Well, it starts with the absolute smallest piece of the puzzle it can find. And that tiny piece is the pixel. You can think of it like a single tile in an enormous, complicated mosaic. Every one of those little tiles has a specific numerical code for its color. So a computer's first job is just to read the code for every single one of those millions of tiles. And this, right here, puts the whole challenge into perspective. The computer has to become a kind of digital detective. It's staring at millions of numerical clues, and its whole mission is to solve the puzzle. What do all these numbers actually represent in the real world? So where does any good detective start? You don't get lost in the details. You start by looking for the most obvious clues, the stuff that really stands out. For a computer, the first and most important clues are edges. It scans that whole grid of numbers and looks for places where you have a really low number right next to a really high number. That sudden, drastic change almost always means one thing. You've found the border between two different objects. But how does it find these edges? It uses these clever little tools called filters. The best way to picture them is as digital magnifying glasses. They just slide across the image, row by row, and they're specifically designed to spot the exact numerical patterns that basically scream, hey, there's an edge here, or look, that's a corner. Okay, so our digital detective has found the basic clues, a whole mess of lines, curves, and corners. Now comes the really cool part, connecting all those dots to see how these simple little features build up into something we'd actually recognize. The whole process builds up layer by layer. First, it finds the simple edges, right? Then, it starts combining those edges to find simple patterns and textures, like, say, the weave on a piece of fabric. From there, it combines those patterns into basic shapes, circles, squares, you get the idea. And finally, it assembles those shapes. It sees a circle on top of a rectangle next to two other circles, and because it's been trained on millions of images, it makes the connection. Hey, that specific combination of shapes, that's a car. And what's the brain running this whole detective agency? It's a specialized kind of AI called a convolutional neural network, or CNN for short. Now, you don't need to remember the name. Just get this. It's an engine designed to do one thing really, really well: recognize patterns in visual data. And it gets better and better at it the more pictures it sees. So here's why this all matters. This isn't just some cool theory. This digital detective is working for us, all day, every single day, in ways that are literally shaping the world around us. For starters, every single time you unlock your phone with just a glance, that's a CNN at work, identifying the unique patterns and shapes that make up your face. Or when you scan a QR code, your phone isn't just taking a picture, it's using computer vision to instantly identify that specific pattern of black and white squares to pull up a website. And this one is huge. Self-driving cars rely completely on computer vision. It's how they can tell the difference between a person, a stop sign, and the lines on the road, all while processing it in real time to keep you safe. In medicine, this technology is an absolute game changer. It helps doctors scan things like MRIs or X-rays to find really subtle patterns that might indicate a disease, sometimes way earlier than the human eye can catch them. And in security, well, it's the difference between a camera that just records footage and a system that can actively understand what it's seeing, like spotting a person where they shouldn't be. So we've gone from a simple grid of numbers to a machine that can identify a face, drive a car, and even help spot disease.
It just goes to show you teaching a computer to see is really the first step in teaching it to understand, which leaves us with a pretty fascinating question to think about. What are they going to understand next?